Welcome back to the workbench. Hopefully in this package we have something else to work on, something interesting. Alright, this should be an original Nintendo Switch. And it looks like it is. Well, it's packaged pretty good. All right. Oh, it's in pretty good shape. Looks like it has a screen protector on it. Not bad. Some scratches on the back. Let me take a quick glance into this charge port, which looks pretty good. Although sometimes I can't see it just under the magnifying glass. Let's check current draw. Nothing. Because this, well, like it blinked there for a second. Okay, what does that mean? The light shuts off on this ammeter. That's weird. Yeah, the backlight shuts off on this little meter. But the display stays on, it looks like. But no current. Something weird is happening there. I've never seen that before. Okay. I guess let's get the back off. I tell you what, let's look into that port with the microscope. That's a good place to start. Let's take a look down on this port. Maybe a little more light down in there. I'm not seeing any bent pins. But right in there, it has that look of a slightly melted port. Slightly. Okay. I guess it's time to take it apart. Well, she's disassembled and several of the screws are stripped out, so it took me a while. It was a struggle. So it's been opened, and the one under the little kickstand was also missing. So yeah, not exactly a virgin console. And taking a look under the microscope, Wow. That is a rough looking port. This poor thing. It looks like it was put on with a blowtorch. I hope that's not glue. No, it's not glue. Some kind of flux. But wow. You poor thing, you. And what is this going on over here? Make sure that's in the frame. Just a glob of solder. So anyway, I think we see why we're shorted. There's a lot of stuff shorted there. I'm not sure what's going on up here. Yeah, it's just a piece of plastic from the port. Lots of flux all the way up here around the M92 I see. Well, this could be a fun one. Not really. There on the BQ I see looks clean. That looks slightly melted here. Speaker connector. Speaking of speaker connectors, the wire's broken on this one on the other side. It's still here, it's just broken. So, yeah, that's right. Maybe I'll try. I don't know. I could put a no good battery in here and see if it will fire up, but I kind of hate to even put a battery in this thing until that port is pulled and all this goodness is removed here. So I think that's my next step. Well, the circuit board is out, and here's a shot of the other side of this USB-C connector, and it is well done, or overcooked, however you want to look at it. I kind of feel bad putting any more heat on this board to remove this connector, but I'm gonna kind of have to, but I do feel bad about it. It looks like it's seen quite enough heat. Alright, well, we've got the port off, and let's look at what we're working with here. You can see we got a couple of lifted pads, and these are going to be fun to repair because I can barely see some copper down in this hole. There was a via going through the board there, so I'm not sure what I'm going to do about that. If I'm going to, run a jumper wire from the other side around here to this pad, or just dig down for that copper, which is probably I'll probably do that. I'll probably just dig down for that copper and lay a wire down in here. And here we got a little bit of the pad, left, just a little bit. Maybe it's enough to tie to. So, but before I do any of that, I want to see if this board is even worth working on any further. Do some basic checks. What I'm thinking I'd like to do is put it back in the housing without the port, with a charged battery, and let's see if it'll actually boot. So let's do some checks around the M92 IC. If I can get things in the frame here. Let's see, what do we have across some of these capacitors here? Nothing there. No shorts. That must be, that must be ground on that. Well, neither end of that one's ground, is it? That looks normal. That looks normal. That's not normal. A short there usually means there's a problem on the P13 IC on the back side. Let's flip over there and take a look. Okay. I'm going to guess we have a short across this capacitor. Yes. So most likely this chip has got to be replaced before we can test it any further. How about some of these filters over here? Good. Good. Not shorted to the other side. And the last one is not good. She is open. She's seeing too much heat. Okay. So we've got one filter we got to change as well. Oops. Not sure if that was in the frame. This one here seems to be no good. So we need a P13 IC and one filter. I'm not sure if I've got a donor to pull one of those off of or not. I'll have to look and see. So hopefully once we get that replaced, we can actually put this back in the chassis, test it, and see if it's worth putting a port on for it and doing the trace reconstruction. All right, here we are. I've got it back in the chassis. The P13 chip on the back has been replaced, along with that filter that was open. No port installed. Let's see, I did reconnect the touch sensitive part up here, because if this were to magically somehow turn on, it would be nice to be able to actually log into it. Fans reconnected. I charged this battery off camera yesterday. I left it charging for a while at 100 milliamps, up to 3.8 volts. So hopefully we got enough charge on this battery to do something. Just put it back together. No heat sink. Let's see if we can reconnect this battery. There it goes. I haven't put any screws on the circuit board yet. Let's see what we have. Anything? Yes, Nintendo. Give me a Switch logo. Yes. There we are. How about some touch? Yes, I think the volume is turned all the way down. No, one of these speakers may be shot then. Okay. Yeah, we've got, look like 40% or so battery. Parental lock is on. That's a pain, but we can fix that. Yeah. I think we have a working switch. We can't charge it, so that means I'm going to go ahead now with the trace repair around the port and put a new port on it. And see what we have then. Alright, well, we've done some trace repair. We've installed a new port, and we are at the point of seeing if we've done any good here. Let me reconnect this battery and get my ammeter in the frame. Let's see if we can do this now. There we go, 0.47. We are charging. That's good. All right, how about? Oh, I guess she's gonna boot up, isn't she? Or what are we doing? Are we in the? We're only drawing 100 milliamps. I guess we're slow charging. But we are on. Okay, what I'm really going to have to check is, will it dock after this port replacement? And some of the traces that were damaged, like the one over on this side, was a USB data pin. So I need to make sure while it's in the dock that the USB devices, I've got a USB controller I'll plug in there, need to make sure that works so that we have, full functionality. Okay, we are not fully reassembled yet. I don't have the back on it yet, but I want to see if this thing will dock. It's time to find out. I see a green light. Hey, there we go. Right now, do we have a controller? Let's see. What do we have to do to get this controller to work? Maybe we don't have a controller. Oh, we still have a problem to fix then. No USB. Darn. Back to the drawing board. Well, we are back under the microscope, and I think I figured out why our USB controller is not working. Our damaged pads were here. I think this is SBU1, and one of these over here, which is like the TX1 pins. And I thought this one was over here was related to USB. It's not. Don't let the SBU name fool you. It has nothing to do with USB. That's handled by D plus and D minus pins, which are in the middle, and those connect to right here. And those connections are good. So I followed it on up to here, and one side of this filter is open. I think it's this side over here is open. This side still conducts over here. And that's when things go, the news is not so good. The filter is not the only problem. I can get a diode reading on one of these pins, with red probe on ground, doing a diode measurement to each one of these pins. I get 0.7 on one and nothing on the other, which means it's totally open. And these leads, these tracks right here, go through a via here through the other side of the board, and eventually it leads straight over to the CPU, which is the bad news. I believe our CPU is damaged. It still operates, but I believe the USB portion of it is done for. I'm sure what happened is this. When at some point when these pins were crossed up, the contacts inside this connector were crossed around in some ways, 15 volts ended up going to the CPU, just like it also went to that P13 chip, and the damage is done. I can replace the P13. I can't really replace this processor very easily since it's tied to other chips on the motherboard. So that's probably how I'm just going to end this one. Is it's a working switch. It should work. It works fine with controllers, the Joy-Cons, and it should work fine. I'll test it with a wireless controller. But that's probably how I'll be trying to sell this one, is that, okay, works fine if you want to use a handheld or if you want to use a wireless controller, but no USB. So not much I can do about it, but that's it's still a successful repair. We've done our trace repair down here. We got a new port on, replace that P13 chip, so we have it will work on a dock, assuming you have a wireless controller. So that's about all for this one. If you enjoyed that one, thought it was entertaining, educational, or just even mildly interesting, please give me a thumbs up, and I will see you in the next repair. Bye for now.